Hello, I'm Sonic. We will learn about arithmetic and geometric progressions. Here an arithmetic progression is a sequence of numbers such that the difference between the consecutive terms is constant. The difference here means the second minus the first. For example, in the ascending order, many rings I want to collect it in a row. Here goes the sample, with difference of 3 and the first term of 1. The formula is nth term, probably an, equal to first term a1, plus difference times n minus 1. We have d is equal to 3 and a is equal to 1. If I need a fifth term, say, n is equal to 5. Then a5 is equal to first term 1, plus 4 times difference, the answer is 13. If we move to descending order, then the difference has to be negative. Same way, for example, taking the first term b10, then making a difference of minus 3. Similarly, if we make a sum of sequenced numbers, such that the formula is sum of natural number Sn, equal to, n over 2 times the first term, plus n minus 1 times d. Let us consider 5 terms, first term b2 and a difference of 4. Then Sn is equal to 5 by 2 times 4 plus 16. The answer is 50, same as 2 plus 6 plus 10 plus 14 plus 18. These are arithmetic progressions. On the other hand, the geometric progressions is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed, non-zero number called the common ratio. The formula is ar to the n minus 1 exponent. For example, take the first term 2, and a common ratio of 2. If we take the fifth term, we get 32. By taking the sum of geometric progression, Sn, is equal to first term times r to the n exponent minus 1, divided by r minus 1. Or, if you have written 1 minus r to the n exponent in the numerator, the denominator should be 1 minus r. This gives the answer of 62, which is same as 2, plus 4, plus 8, plus 16, plus 32. These are called geometric progressions. Like, comment, and subscribe now.